heat pumps. So this one is not a called air source heat pump. This should be called the water source heat pump. Yeah, ground source. Yeah, so normally there's a like the well or some like the big water pond. So you can use a loop like this. So this one, so it's normally like we use a coil. So for example, is an air conditioner. It's same. Outside is condenser. It's blow the the heat out, and the inside is a coil. Is a evaporator. Yeah. So if it's a heat pump, it's in winter time just reverse. Yeah. So the only thing different is normally air conditioner is an air source. So use air to cool down heated. Yeah. So the water source is use the water. This just look like a boiler, Okay, so this is the air source. Air source just like our forced air furnace. Yeah, so use the air, so heat or cool. Yeah, so and the grounded this water source is like the boiler. Use the water to dissipate heat or suction the heat. Okay, so this one we talked about already. Yeah, so this one, hey Alex, I didn't understand why put this one here. So can you explain for this picture?
Yeah, you bet. So this is just a really basic schematic of a heat pump. So as Sam just mentioned, heat pumps, they work very similar to fan coil units. Except that you have, your glycol that would be providing the heat source or the cooling or what have you. So if you imagine, you just basically have a big coil unit inside the main cabinet. You'd also have that reversing off if there's an AC capability with the heat pump. The big thing is you want to be checking for any sort of leaks with the glycol system. Of course, if there's any sort of electrical backup systems, as you can see here on the left-hand side, the auxiliary heat supply, you want to be checking for any sort of scorching, because most of these heat pumps, they work fairly well up until about -25 Celsius. And after that, that's when you need to get that supplementary heat going. And usually what you'll see is just like a toaster, just like electric radiant heat that will heat up to assist with additional heat for the house. Typically with these heat pumps, you'll notice that the duct systems are actually quite a bit larger than your forced air furnace, just because, again, you usually have to move a lot more volume of air. That's typically not as hot. So a lot of people, if they're not used to a heat pump system inside a dwelling, they might find it a little bit cooler than a forced air furnace, or even thermal heating, like hydronic heating through a boiler.
Okay, thank you. Yeah, so
and these systems, they're generally fairly low maintenance. Again, you just want to be checking for the scorching. Like how you inspect the fan coil unit would be very similar to how you'd inspect a heat pump system. Of course, you're not going to be able to go into the ground or into the pond or what have you to check the integrity of the system. But obviously, if there's any sort of grinding noise, that may indicate there's a low a low glycol level. Again, scorching, check out the filters and any sort of disconnects. Make sure that they're actually available, because again, you will have electrical components here, especially if you have that supplementary auxiliary heat source.
Yeah, I think most like the boiler. So there's a water leak, or the filter clogged, and another thing is the blower motor. So that's the main troubles we come at maybe.
Yeah, there's probably gonna be a really big push towards heat pumps here in the next few years, because heat pumps, if you couple them with solar systems, photovoltaics, it can actually be 200-400% efficient, just because you're getting free energy, and now you're also grabbing energy from the ground as well. So again, kind of expect to see a lot more of them here in the future, kind of like electric vehicles.
Okay, so hydronic heat pump schematic. So this one just show us the how the hydronic heat pump works. Yeah, so we need the ground well. Yeah, so that's heating source come from. Yeah, so on the pump. Yeah, so the coil heat changer we called. Yeah, so the water tank. Yeah, and after that there's like a mixing valve. Yeah, so the loop temperature controller. Yeah, so this go inside the house is different zone. So the room thermostat control the room zone. Yeah, so this is just like the boiler. And the oil furnace is not common to see. Yeah, just like I said, I only saw 1-2 times in Saskatchewan. So it's only for the commercial building. Yeah, so the main thing is for the boiler I met is the orifice. The orifice is easy to clog. Yeah, so we see this like the normal the furnace, the need the burner, but this burner is special. Is there's a motor there? It's below the the oil inside. Yeah, and then makes the air is easy to burn. So burner control. So it's limit switch. So this one just like the furnace, there is a high limit switch, clean out port. Yeah, so flue opening, clean out port, observation port. So this one we can see the flame inside. Yeah, so the indoor blower. Yeah, so this one should seem with a furnace. Yeah, this one not normal. Yeah, but if you see, yeah, so if you see the outside, there's like a black tank there. Yeah, so normally there's the oil furnace or oil water heater there. This the special burner for the the oil furnace. Yeah, we can see here is a small orifice. Yeah, so the whole thing here is a called nozzle. Yeah, so when this motor is running, is just the pressure the oil mixed with air, just blow out from here and mix air and inject to the heat changer. Yeah, this is a same function. The flame retaining head, control box, this transformer I cannot see here. It should be transformer. Yeah, fuel line. Yeah, this air control, oil pump, delayed action solenoid valve. Yeah, so this one, so we just know roughly. So because like the oil furnace, we need the professional guy go there check every year. Oil boiler is the same with natural gas boiler. The difference is only the fuel is oil, is not a gas. The other should be same. So water heater is the same, different fuel. Yeah, so the other is the same. So for the water heater, so another thing, so is an anode rod. So we should change anode rod every maybe 3 to 5 years, just depend on the water quality. Yeah, so and how many water you use for the house. Yeah, so normally there should be a sticker and make notes when they change the anode rod. And if you saw is all over 3-5 years,